Using inductive reasoning to make conjectures. Our objectives are to use inductive reasoning to identify patterns and make conjectures, as well as find counterexamples to disprove conjectures. Who uses this? Biologists use inductive reasoning to develop theories about migration patterns. Let's try identifying a pattern. Find the next item in each pattern. We'll do the first one together, and then you'll try the next two on your own. Monday, Wednesday, Friday. Alternating days of the week make up the pattern, so the next day is Sunday. Take a moment and pause the video and try the next two. Well, we have 3, 6, 9, 12, 15. They're multiples of 3. So the next number would be 18. And we've got one arrow to the left, then one going up and to the left, and then one going up. So the next one in the cycle will just go up and to the right slightly. Let's look at a couple vocabulary words. Inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. Basically, draw a conclusion from a pattern. A conjecture is a statement you believe to be true based on this inductive reasoning. Let's make a conjecture. The product of an even number and an odd number is, well, you can do some things like, okay, even number times, because we're dealing with product, times an odd number, and well, 2 times 3 gives us 6. Let's try another one. Let's go with 2 times 5, an even times an odd. Well, that gives us 10. Let's try one more. What about 4 times 3? Well, 4 times 3 gives us 12. So the product of an even number and an odd number is even. Let's deal with a biology application. To learn about the migration behavior of California gray whales, biologists observed whales along 2 routes. For 7 days, they counted the number of whales seen along each route. Make a conjecture based on the data. Well, if we look at direct route, they saw 1 whale, 3, 0, 2, 1, 1, and 0. Along the shore route, they saw 7 on the first day, 9 on the second, 5, 8, 8, 6, and 7. So you might make a conjecture that more whales are seen along the shore route each day. So more whales are seen along the shore route each day. Let's take a closer look at what is actually happening when you're doing inductive reasoning. To show a conjecture is always true, you must prove it. To show a conjecture is false, you have to find only one example in which the conjecture is not true. That's called a counterexample. It can be a drawing, a statement, or a number. So when you're dealing with inductive reasoning, first look for a pattern. Then make your conjecture, a statement you believe to be true based on that pattern that you noticed. Then either prove the conjecture or find a counterexample. Let's look at finding a counterexample for different examples. Show that each conjecture is false by finding a counterexample. For all positive numbers n, 1 over n has to be less than or equal to n. Can you come up with an example where this would not be the case? Take a moment and pause the video and try this one. Now that you've had a moment to try it, let's try it together. What if you used a fraction? So what if we used 1/2? Alright, well, it's a positive number, it's not negative, and we'd have 1 over 1/2. Is that less than or equal to 1/2? Well, 1 divided by 1/2 is actually 2. So 2 is not less than or equal to 1/2. So we found ourselves a counterexample. Let's look at this next one. For any 3 points in a plane, there are 3 different lines that contain 2 of the points. Can you find an example when this does not work? Let's take a look. Well, if the 3 points are collinear, then you can't draw 3 separate lines through them because they're all on one line. Let's look at this next one. The temperature of Abilene, Texas never exceeds 100 degrees Fahrenheit during the spring months, which are, by the way, March, April, and May. Well, let's look at the table. March, April, May. Well, March is 97, April's 99, and May is 107. So I feel like we have found our counterexample. The temperature in May was 107, so therefore you have found a counterexample. Well, that concludes our lesson on using inductive reasoning to make conjectures.